Hello fellows, so this is another tutorial for the ADC, but this time it's a little bit special. So you're going to see here that I'm moving the potentiometer where the reading, there's nothing for the reading, to a certain point. So you see here that I'm moving again my potentiometer, but nothing is happening in the reading until I reach a certain low value. So there is kind of a boundaries that we are using, and we call it a watchdog, that allow us to execute the program when the ADC value is within certain perimeter. So if you are interested to learn interrupts and watchdog, just follow this episode. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. This is the WeeW, and you will learn how to set up interrupts and watchdog for ADC of the STM32F1. As usual, the code that we are going to write together is available on GitHub. You can find the link in the description below. Also, the language that we are going to use is only C language. The program to code is Scale version 5. Finally, you may need to take a look in some previous video to understand in details the function that we are going to use immediately, but if you are interested to understand how the interrupt and watchdog are working, you can just follow this episode and you are doing just fine. For the hardware, we are going to use the STM32F1 based board, which is the aka blue pill, and also an FTDI to establish the serial communication or the UART communication with the PC. Then a variable resistance or potentiometer to make some testing and to see the impact. Finally, if you'd like to be fancy, you can add some LEDs to make some signaling, and this is more for the example of the watchdog, but this is not necessarily for the LED. You can use the LED in the board of the STM32F1 blue pill, and that will be just fine. Okay, so let's go to the tutorial. So it's a very simple tutorial. First of all, let's have a small refresh about the ADC interrupt and watchdog. Then we are going just to go and start coding the interrupt for the STM32F1 ADC. Finally, we will set up the watchdog and have a very simple test to understand how it works. So let's go first and have like a review for the ADC interrupt and watchdog. So first of all, let's have an interrupt 101. So let's make the comparison between the program with no interrupt and the program with interrupt. Okay, so in the program with no interrupt, we do have the main thread where we will have a wait time for the ADC. So we need to wait until the ADC reads the data and ready. Then we are going to get the ADC value or the read value from the ADC. After that, we are doing some stuff or other stuff, and here again. So you can see that there is a huge waiting time for the ADC that the microcontroller will waste just for waiting. And then if we go to the other one, in the interrupt mode, there is the interrupt thread that will be waiting for the ADC, like waiting until the ADC gets the data and will generate a signal. So this signal, then we are going to use it in the main thread here, and each time we check if there is no signal, we just do other stuff. If we do have other like we do have the signal, we get the ADC value, and after that we run again. So you can see the saving of time is huge because we are not going to wait. Okay, so that's the difference for the interrupt, and we will see later in details how we are going to program it inside the STM32F1. Okay, so let's take a look to the watchdog. The watchdog is much simpler than that. So you can see this graph here. So it's an analog watch that check the data between higher threshold and lower threshold. So if the value goes over that area, like higher or lower, we will have a kind of a signal. So in other words, this can be used when reading the value is not really needed, but we would like the microcontroller to operate in a specific way where the ADC value is out of a certain range. It means we don't even need to get the value, we just look if we have a signal and we are out of the area, and this is really useful if we really don't need it, and that's less operation to manage. Okay, so now that we have a small idea about both interrupts and watchdog, let's jump and set up our interrupt for the STM32F1 ADC. Before jumping to the code, so let's quickly take a look to the circuit. Very simple one as usual for the moment. So we do have our potentiometer connected to PA0, and also we do have the FTDI connected to our UART to send the data later on and to make the reading. Okay, that's a quite simple circuit. We can jump and quickly start making the code. So for the code, I prepared some stuff so we don't waste our time. Here we add the two libraries we created in the previous tutorials. The first one, ADC drive, is to set up the ADC peripheral and start the reading. And this one, message drive, is the one to customize the message to be sent for our special Python reading program that we also made a tutorial about it. Here, so we are initializing the systic, which is the delay function. Then we are going to initialize the UART init to make the communication with the computer using the UART communication. And finally, we are initializing the ADC1 port A pin number 0. Okay, that's really simple, and this is what we have been seeing in the previous tutorials. So now to activate the interrupt, we have to jump quickly to the reference material so you can have an idea how this works. So if I go reference material, we take a look to ADC. Where are you, ADC? ADC, probably you are seeing it. Yeah, this is here. And we jump quickly. So interrupt, if you read here quickly interrupt, you can see that the interrupt is generated by each time the conversion end, and which is the flag or EOC. So we will see the flag quickly. And to generate to move and to have the activated the interrupt, we have to go for the control one, and we take a look to the pin. Which one? Let's look for it. So the control one register, and somewhere we have to find, just a moment, let's scan mode, enable interrupt for injected, no, not channel, enable interrupt analog watch, interrupt enable for EOC. Okay, this is the one that we need to enable. So what we need to add immediately after this code, quite really simple and easy, we just have to put ADC1, and we need to put for the control one register, and we put or equal the 0x2 20. So if this should be the bit number 5. Let me go back again and check. So it's a bit number 5, so it's a 20 hexadecimal. Okay, so this will activate the interrupt, but still we need to activate the function for the interrupt. So as usual, as we have seen for some other tutorials, so we have to do disable IRQ, no, not the disable IRQ, not NVIC disable IRQ, that's not what I want to do. I have to do disable this one, IRQ, and after that we have to enable, so NVIC here, enable IRQ. We need to enable the ADC 1 to this one. Careful guys, sometimes it's easy to make a mistake during the typing, and after that we just enable IRQ. Okay, you see the steps here are really simple to manage, should not be very hard. So doing this one, we should be able to be ready to use our IRQ. So now, and you could see also it's ADC 1 and 2. So this interrupt is available for both, and when we do have an interrupt, it's for both ADCs. So be worried later on when we set up our interrupt function, we have to be quite worried to confirm if it's ADC 1 or ADC 2. So ADC, okay, 1, 2, IRQ handler. I hope that I will write it correct because I usually do some mistake on this one. Okay, Okay, I think the RQ handler is correct. So here I would like to specify, so I will come here, just added all the channels that we do have, just in case you wonder which pin it can be used as ADC and which one cannot. So this is the list for the STM32F1. So let's go here and put two small flags. So we've got int equal, so we're going to use only ADC1, so int, and let's call it for this one ADC1 interrupt, and we are going to put it equal to 1, where the other one, int ADC2 here, will be equal to 0 because we are not going to use the interrupt for the moment. So let's go here and we say if int ADC1 interrupt for this one. So if we do have an interrupt happening, so that's the first thing to confirm. So first of all, we need to do is to stop the interrupt that we made, and if we don't do it, it will stay forever within this loop. So what we have to do is and the opposite. So here we close our interrupt, and after that we can just read our data. So let's take the data here. So let's make another int here, int, and let's call it analog Rx, okay, equal 0 initially, and this is the data that we would like to read. So this one will be equal to the ADC1. Let's put ADC1 and here data register. Okay, so this is when we read. Now what we need to do is to give a signal for our while loop, where our main program or our main thread here, that we are starting, like we got the data. So let's have another one, we call it, so here let's call it an ADC1 flag, for example. So int again, or for this one even char should be fine. So ADC1 flag, okay, and we put it equal to 0 initially, so it doesn't go within the loop. So if ADC1 flag, ADC1, okay, ADC1 flag, okay, so then what we can do, so first of all we always put the flag equal to 0, so it doesn't enter again within the loop. Okay, so the flag is equal to 0, and we put here, so as soon as we start reading the data, we put the flag equal to 1, and that's all. So that's all for the interrupt. So let's add the ADC2 to have a complete job for both. So ADC2 interrupt, and this one ADC2, and ADC flag. Don't forget again, each time you read the data and you learn the flag, if you would like to keep it, you have to put again the that you want to read again from the interrupt. So let's add also quickly, what shall we add? Let's play a little bit with the data. So what we are going to do, we take this analog, okay, something I didn't add, let me add this one too, ADC2 here. Okay, so let's play a bit with the data. So let's take the analog read, this one. Of course you can change analog to 1 and 2, but here we don't need it. It just to have a general example will be equal. So what we are going to do is taking this analog and multiply by 1000 to get a value between 0 and 1000, and divide everything by the full range, which is the 0xFFF hexadecimal, and this will give us an integer between 1000 and 0. Then what we can do, simple basic message, and this is a function that we are getting from the message drive, and this is what we will send through UART the message. So we will send the analog, let's send this data here, Okay, that should be good. I forget, we have to select, this is the UART2 that we are going to use, and we are going to send this message. So you can see here, so we can put read here and keep waiting, but the time that is saved is huge in this example. So we just spend the time here to read the data. We don't need to wait until the new data is coming, which is extremely helpful to make these kind of activities. Okay, that's really good. So let's first save and build to see what's going on. It's a 0 error, 0 warning. So let's build it and load it in the microcontroller. So let's take a look here. This is our microcontroller, and I'm going to use this animated terminal that we created together. Okay, let me put enter here. Okay, something is not going right. Okay, Python animated terminal. Okay, good. So I will start moving this one a little bit, and you can see that it works like a normal one, but inside is more effective because we are going to use an IRQ. So we see here, this is the maximum value. You can see the reading is quite smooth and there is no issue at all. So this is how we use the interrupt for the ADC, which give us a lot of time saving and a more effective way of reading the data. We just have completed the setup of the interrupt for the STM32 ADC, and you could see how easy and straightforward it is. So also the watchdog is also quite simple, and you will see how useful it can be. Let's go back to our main code and comment the part where we are going to use the interrupt. So this one is setting up the interrupt. Okay, the normal interrupt. Okay, so what we are going to do now is to put this one to 0, and we are going to take a look on the reference manual where to find the watchdog. So the watchdog should be somewhere also in the CR1, and it should be like, let's go back at the top here. Yeah, it's in front of us. So analog watchdog enable for regular channel. However, this is not the only one that we have to put. So this one should be, this is number 23, so it's 80 hexadecimal plus 4 other zeros. We should also enable, let's go down, oh god, let's go back here, let's go to this one. We have to enable, so the first one, enable the watchdog, that we are going to use the watchdog. The second one, which is this one, we have to analog watchdog interrupt enable. So we do have, so the first one is to be enabled only once, but the second one is the one that we have to enable each time. Okay, so this is a bit number 6, which means a 40 hexadecimal. Okay, and beside that, we have to give a certain value to this high threshold and the low threshold. We will take something arbitrary, but just to see the example. And to make our example more easier to understand, let's enable the green LED in the board, so digital output, and that will be the PC13, which is the port C pin number 13, which is connected directly to the LED. Okay, so here, instead of putting ADC for this one 02, let's copy the same, and we are going to put for this one is 80 hexadecimal because it's the first one, and we are going to add 1 2 3 4 5. We do have, this is how we enable here the watchdog. Enable the watchdog. Okay, after that, let's take the ADC one and let's see the high threshold, and let's put equal to 0x. Let's see the C00 hexadecimal. We will check later on and we'll play a little bit with it. And same form, let's take the low threshold, the lower threshold, and we put a 500 hexadecimal. Okay, and finally we have to enable or activating the how to say it, the watchdog interrupt. So let's bring it this one again, or even better this one. Okay, and let's check again, not this one, let's check here. So we do need to go for this one. Number 6 means a 4 hexadecimal. Okay, so for this one it will be a 4 hexadecimal, and we do have everything ready. Still, when it's linked to the same IRQ handler here, we need to add another 2 ones as usual. So instead of interrupt, we call them watchdog. That will be simpler to manage like that. So let's go here, and this one will be a watchdog and another watchdog. Okay, so what we have to do here, we don't need to read any data, and that's the magic things. We just would like to get some information, so we can read the data. There is no issue at all because the threshold is ready. But yeah, let's do it. Well, that's fine, but we still don't need to read any data. So let's go here, and here let's take the watchdog, and we are not going to close. We need to set up this one to 4. We are going to read the data, and this is our flag. At the same time, what we can add here is we can put the write on the general purpose pin for the PC13 for the PC13, and we put it as a low. So when it is low, this is like a reversed one, the LED will be turned on, and outside of this if we do not have the flag, it will be high, so the pin will be off. Okay, here will be this one low, this one will be high. Okay, and instead of activating the interrupt, we are going to activate again the watchdog. Okay, so we will be this one high and low. So let's add for this one here, the ADC flag is good. So let's put there's something before doing so there's something extremely important we have to review too. So the watchdog interrupt is closed only when this one is put to 0, the watchdog, the analog watchdog flag, and this bit set by hardware when it's the voltage moves, but it's cleared by software. It's extremely important. You have to clear this bit by software, else you will stay your loop will keep staying inside here. So not only you need to deactivate the watchdog, you have also to deactivate the bit in the status register. So ADC1 here, status register, and we need to put and equal, and we just put a 01 hexadecimal and here. Okay, that should make everything good for the watchdog. And let's jump here and change the 2 here to 2, and this one 2, this one 2, so we do have everything ready and set up. So let's check here again one last time. So the flag has to be equal to 0 so we don't get inside. We put this one to low, so the pin, not the pin but the LED will be turned on and reading the analog, and we will be providing data between 0 and 1000 and then sending it through UART. Okay, let's run. 0 error, 0 warning. So before doing anything else, this is our old program, the one for the interrupt, and you can see that it's working smoothly. But now what we do expect is if the potentiometer is between both values, nothing will happen. But if it's outside the values that we have set up, we should see this LED turning on and this value changing. But if it's inside, nothing would happen. And start doing the code. Let's put it and let's load. Okay, so let's see here. So you see I'm moving here, but nothing happened. But if I go more to the extreme, okay, keep nothing happening. So let's check, something was made wrong. So let's check here. So this one is correct. We are setting up the watchdog on place, and after that we are putting this one to 0, this one to 0. So this flag going well. Let's check again. Okay, what we can do, we may close this one, rerun it again. Okay, there is no data coming, so let's confirm what's going on. So I think I know what's going on. Yeah, the watchdog have to be 1 because we are going to use the watchdog. So let's save, build. So we are going to use it, that's why I need to put it to 1 and build. Now we should see something. Okay, yeah, you see, so I'm moving, let's showing this one. So I'm moving here, I'm moving it, but nothing happening until I reach a certain degree. And you can see also the LED. So I'm moving this one until I have a certain point that I reach. So let's make the extreme further. So for this one, let's put a D and this one 2 to make it further. I like to see how much I can turn the potentiometer without having nothing. Okay, so now let me show you. So I'll be here. See, nothing is happening until almost 0. So I'll reach this value and then it gets frozen at 400 millivolt, 409, and then it backs again when it's 2400. Okay, you can see with the LED turning on and turning off, you can see how many potential you can. You don't even need to read the value. So this is more if you would like your program doing something to a certain value. Okay, I hope you enjoyed this video. Thank you a lot, and WeeW.